The next category is graphing quadratic and linear systems. So on the set of axes below, solve the following system of equations graphically and state the coordinates of all points in the solution set. So we have y is equal to negative x squared minus 4x minus 3 and y is equal to negative x minus 7. So we're going to move the parabola by dragging the dots and graph the line by clicking twice. So you just click 2 spots and then you will have your line. So in order to do this one, it would be easiest to literally type this equation into what's it called? Desmos.com. So you go to desmos.com and then you click graphing calculator, which is this button right in the middle in the center. And then negative x squared minus 4x minus 3. So negative x squared minus 4x minus 3. Let me just double check, did I type it right? Negative x squared minus 4x minus 3. Negative x squared minus 4x minus 3. Okay, cool. So now this is what our graph looks like. Noticing like the vertex is at -2, 1, and then there's a point at 1 or -1, 0. So I'm just going to use those 2 points to help guide me in shaping this parabola where it should be. So the vertex is at -2, 1. So I'm going to drag this green vertex to -2, 1. So now we moved left 2 and up 1. We just need to flip this, parabola upside down. So in order to do that, I want to make my parabola intersect at -1, 0. So I'm going to grab this blue point and drag it down to -1, 0. So now I've effectively dragged my parabola over to the left and I flipped it upside down simply by moving around the green and blue points. The green point is important because it's your vertex and the blue point helps you flip it and stretch it or compress it however you like. So this is our parabola. So that part's good. Are there any questions up until here about this parabola? So the next one we want to do is graph negative x minus 7. So I'm going to go to Desmos and type negative x minus 7. Oops, minus 7. So you can see that this line has a point at -7, 0, and I can click and drag this to move it. And then also a point at 0, -7. So I'm like, oh, okay, so let me put those 2 points on this graph. So scroll down, -7 and the -7. So this is my line. And all I did there was literally just pick any 2 points that are in this on this blue line, because we just typed the blue line's equation and then you just pick any points. I could have picked -7, 0, and also I could have picked -6, -1 as the 2 points that I click on Delta Math. It doesn't really matter what 2 points you choose. You could have chosen this one, you could choose this one. I'm trying to make it the whole number. You could choose this one, like it really doesn't matter. But anyways, I chose the 2 intercepts, and so here they are. Here's our graph. And finally, you look at how many intersection points there are. Notice that there are 1, 2 intersection points. So therefore, there should be 2 solutions. Notice that the options are no solutions, 1 solutions, and 2 solutions. So in this case, we have 2 because it touches twice, okay? So 2 solutions. And then in those, we're going to type it in the parentheses because these are coordinate points. So coordinate points need to be put in parentheses. This first point right over here is -4, -3. And then for the second point of intersection is right over here. So that's 1, -8. Let me put my mouse over it again. This one is 1, -8. Remember that when you are typing points, you need to have parentheses, number, comma, number, parentheses. So these are how you type your points. Are there any questions on this one? Submit. And let's do 2 more from this one. So here we have the instructions. I'm going to read it. On the set of axes below, solve the following system of equations graphically and state the coordinates of all points in the solution set. So we have x squared minus 10x plus 19. Remember, go to Desmos, and I'm going to go ahead and type this in. X squared minus 10x plus 19. X squared, is it minus 10x plus 19, I think? X squared minus 10x plus 19. X squared minus 10x plus 19. Okay, cool. So taking a look at this, we have a point at 5, -6. We also have a point, oh, those are horrible points. Okay, so where is a nice point we have? Oh my gosh, right there. 6, -5. So here's a nice point that we have. So we want 5, -6 and 6, -5. So this is the shape we want. So I'm going to go ahead on Delta Math and drag my vertex to 5, -6. And I'm also going to locate 6, -5 on my Delta Math. First, let's drag our vertex to 5, -6. So that's the green dot, 5, -6. And then notice this blue dot's already on the 6, -5, so we're good to go. However, you could have dragged it everywhere, but we're good to go when the blue dot is at 6, -5. The blue dot being right there, 6, -5. You really just need to find any nice point on this graph, okay? Usually it's just going to be 1 away. So from 5, go to 6. Where is it at? At 6, -5. And so that's why we have this shape. So that was this equation. Now we also need the x minus 5 equation. So x minus 5, notice that we have an intersection at 0, -5, and also at 5, 0. So these are the 2 points I will use to graph my line. So you graph a line by clicking twice. So I want the y-intercept to be -5, and I want my x-intercept to be +5. So I click these 2 points, and then therefore I have my line. And so notice that I have 2 intersection points, therefore I have 2 solutions. All you have to do is just tell us what points these are. So this one is 3, -2. This one, parentheses, 3, -2, close parentheses. And then that other point of intersection is right over here. This is 8, 3. Okay, now before I submit, are there any questions? All right, so we submitted it and we got it correct. Let's see, we can do one more of these just because. Okay, on the set of axes below, okay, I don't need to read all that. Let's graph this. X squared minus 6x plus 9. X squared minus 6x plus 9. Was it plus 9 or minus 9? Plus 9, okay. So x squared minus 6x plus 9, good. Okay, so let me drag this up. So we have a point at 3, 0, and we have a point at what looks to be 4, 1. So 3, 0, and 4, 1. Let's first move our vertex to 3, 0. So literally just moving it to the right, 3. And then look, our blue dot is already at 4, 1, so we're good to go with that. Next, the line 2x minus 3. So for this line, I see I have an intersection point at 0, 3 and 1.50. Well, I don't think we can click 1.5 over here, right? We can only click on the nice points. So I'm not going to choose this one. Let's choose this point. This point is perfectly on the grid, so you don't have to have a decimal. So we're not going to use the 1.50. You can pick any point you want here. I could have picked, trying to find a nice point. I could have picked 1, -1 as well, but I mean, it's really up to you. Just choose any nice whole number points on your red line, and then that way you can click those points on Delta Math. So we have 0, -3, and then, what was it, 2, 1? Yeah, 2, 1. Cool, so here's my graph, my 2 graphs, and then let's count the intersection points. Here's 1, here's another, that's a total of 2 solutions. So therefore, let me first label this one. This point is 2, 1, and that is our first intersection is 2, 1. So 2, 1. Our second intersection point, I have to scroll up. Let me see if I can show both. Okay, I can. Here's our second intersection point is right over here, and so that would be, looks like 6 and 9. 6, 9, and then that would be our second intersection point. Are there any questions on this one? Let's submit. And let's do the next category.